Okay, in this programming problem, we're going to work through the example on page 138 of the text, specifically number 2, dealing with a problem that computes the mean and standard deviation of a set of 4 integer values. Now, there's a formula given in the textbook that involves a square root, that involves a summation, and involves a division. What I'm going to do is show you the code and walk through it line by line. This code will also be available on Angel if you choose to download it and run it while you watch the video. Okay, let's go down to the main function. And here we'll focus in on the first few lines. We want to input 4 integer values from the user. Therefore, we need 4 integer variables. Now I've named them x1, x2, x3, and x4, and I've initialized them all to 0. The first line of code are those variable declarations. The second line of code is for the mean and standard deviation variables, both of which are type double and both of which are initialized to 0.0. The third variable declaration, for summation, is simply a helper variable, one that's going to store the results of an intermediate calculation before we compute the final result. Asking the user for their 4 values can happen in one of 2 ways. We could have 4 separate prompts and 4 separate CINs for each of the 4 integer variables. What I've chosen to do here is have one prompt and allow the user to enter the 4 values separated by spaces. CIN is intelligent enough to be able to take the first value the user enters and put it into x1, the second value into x2, and so on. Note here in our CIN that we have for the 4 variables listed, and each variable is separated by the 2 greater than symbols. These greater than symbols are called the stream extraction operators. We'll learn more about that in the future. Okay, I'm going to scroll up a little bit here. Once we've done the prompting and the input, we want to do the computation. The first thing we need to do is compute the mean. The reason we need that is it factors into the calculation for the standard deviation. Computing the mean is just the same as computing the average. We add up the 4 input values and we divide by 4.0, the number of values. Next, I want to do an intermediate calculation. If you look at the formula in the book, it's a square root, and underneath the square root there's a fraction, or more specifically a division. The numerator of that division involves a summation. I want to do this calculation first. Now this calculation involves the mean, and it involves subtracting the mean from each of the 4 input values and then squaring that result. Here I've decided to use the POW function 4 times to accomplish that goal. First, I use POW to square the value x1 minus mean. I then add to that result, using POW again, the square of x2 minus mean, and so on. At the end result of this statement is that I have the value that represents the summation. In effect, I have the numerator of my division, or specifically of my fraction. The next step is to close the circle, so to speak, by computing the square root of the summation value divided by 3, which according to the formula n minus 1, or the number of items minus 1, which in this case is 3. Now the division I'm doing here will give me the correct result, even though 3 is an integer. The reason for that is summation is a double. As long as one of the operands is a double, I'll get a double result from this division. SQRT produces a double result, the square root of whatever value you give it, and I store that result into the variable standard deviation. The next step is to do the output. I echo print the inputs, just simply telling the user you entered these 4 values. But then I want to output the mean and standard deviation, but I want to do it in a formatted way. I want all the real number values to show up with 2 digits on the right of the decimal. And I always want to see the decimal point, even if it results in 0.00. The next 2 lines here, which I'll highlight, set up cout to do real number output with 2 digits on the right of the decimal. The first line cout.setf means set flag. I'm setting what we call the fixed flag. I always want to show the decimal point, even if the number stored in a double variable is a whole number. It will always show it as the whole number 0.0, in this case 0.00. The second line, cout.precision, indicates how many digits you want to see on the right of the decimal. In this case, I want to see 2, so that's why you see the 2 in parentheses. Once that's set up, this is in effect for whatever follows. The next line, the cout, will print out the mean and the standard deviation with 2 digits on the right of the decimal. Now there's a couple other things in here that are new. First, I have this thing here, set W, and in parentheses 20. One way we can format our output is to specify how much space on the screen the item should take up. I want the next thing to be printed to take up 20 characters on the screen. If the value isn't large enough to fit into 20 characters, it'll pad it with spaces. Either way, what gets printed next will occupy 20 characters or spaces on the screen. The next thing, left, is actually a constant. What it means is the next thing to get printed should be left justified. In this case, left justified within the 20 characters specified by set W. The next thing to be printed, therefore, is the word mean followed by a colon followed by a space. This will be left justified in a block of 20 characters. We'll see this in action here in a moment. The rest of this is pretty much similar to what we've done in the past. Printing the mean, a few endels, and the standard deviation. After that, we pause and end the program. Now I'm going to compile and run this, and we'll see it in action. The prompt says enter 4 integer values separated by spaces. I'm going to keep it simple. I'm going to enter 1, space 2, space 3, space 4. The output I get looks like this. You entered 1, 2, 3, 4, and then the mean and standard deviation are printed. Now I'm going to move this over slightly. Notice where we print mean. We have mean, colon, and then a bunch of white space. This white space, up to and including the space before the numbers, represents 20 characters on the screen. What we've done is print the word mean and the colon inside of those 20 characters, aligned to the left. We don't have to do that for standard deviation because it is a long word. But the two values that are printed for the mean and standard deviation both are real number variables with 2 digits on the right of the decimal. If it needs to round for 2 digits, it will. Here we get 2.50 and 1.29. At this point the program's over, so I'm going to make the window go away. So here again we've looked at a few new things. One is the use of setf and precision to set up your output to format real numbers in the way that you want them. And we've looked at set W as a way to block out a section of the screen so that you can print something within it, and left to specify that you want left alignment or left justification. By default, things are aligned to the right.